Okay, while we were switching videos, I went back to question 4 to figure out what the heck did I do wrong, and I did figure it out. I didn't hit the equals button after I typed this in the bottom. So this 3.55 meters per second squared was what 2.25 plus 1.3 equals. That just shows you why you shouldn't use the calculator for such simple things. And when you hit the equals button, you actually get an A of 0.79447 meters per second squared. This still worked out because I had the right number in my calculator. So when I went on and did the next step, the calculator hit the equals button because it was smarter than me, which was why I didn't pick up my mistake earlier, because you actually get the 0.2163. But down here, I typed it back in, and that was what screwed it up, because I typed in what I thought was the right answer as opposed to 79447 meters per second. And when you do that, then you do indeed get the 11 point whatever it was, 72 newtons that you were supposed to get. So my apologies for that, and I thought about redoing the video, but I figured you probably already figured it out, and so you didn't need me to redo the whole thing. Okay, so my apologies. Always hit the equals button on your calculator. Okay, so back to the question we were doing when the video ran out of time. So here's A, here's B, and here's C. And we're going to do sum of the forces is equal to M total A. So going one way is going to be FGC. Pulling back is going to be FGBX, the guy on the incline, minus the friction on B, minus the friction on A. And it wants to know, it says it descends at constant velocity, which means the M total A is 0. So we're looking for FGC. So we'll take the other three terms over, and they'll all become positive. So FGBX will be FGB, and the x component is sine theta. FR on B will be mu Fn of B, and it'll be positive, and mu Fn of A. Now B is on an incline, so that means its its Fn will be FG B cos theta. A is not on an incline, so its Fn is just FGA. And I haven't written them as mg because I gave you the FG, so no sense finding out what m is and then multiplying it by 9.81. So this will be 25 newtons, and the angle is 36.87. So sine of 36.87 minus the coefficient was 0.35 times 25 newtons cos of 36.87 minus 0.35 times 25 newtons. Okay? And for some reason my minuses just keep wanting to morph into pluses. There we go. They're all actually pluses. And so when you do the math, you get an FGC of 30.75 newtons. So that's part A. Then part B says, what happens if you cut this string? So you cut this string, so now A isn't here at all. So now all you're left with is B and C. And C is going to win, be FGC going this way. Coming back this time will just be two forces, FGBX and F of friction on B. If we do the sum of the forces is equal to M total A, it'll be FGC, minus FGBX minus friction on B, and that'll be equal to MB plus MC times A. Okay, and this time you're looking for A. So A will be equal to all of this stuff divided by the two masses. So FGC, FGB sine theta, and mu FGB cos theta. Okay? And so this is equal to, that was 30.75 newtons minus 25 newtons sine of 36.87 minus 0.35, 25 newtons cos of 36.87. And now the m's you do have to change. So 25 newtons divided by 9.81 is going to be 2.5484 kilograms. And you're going to add to that 30.75 divided by 9.81, which is 3.134, say 6 kilograms. Okay, do the math, and you should get an A of, cheating and looking at the sheet, 1.54. 1.54 meters per second squared. Okay? So there are 4, 5, and 6. Hopefully these are getting better. Number 7. Number 7 says block mass E is sitting on the table attached to 2 cables with A and B hanging over either side. So we have one block here, we have one hanging down here, one hanging down on the other side. This is B, this is A, this is C. A has a mass of 4 kilograms. B has a mass of 12 kilograms. And C is what you're looking for. Okay? The coefficient of friction is 0.25. And it tells us the acceleration is 2 meters per second squared. So we have an FGC going this way. We have an FGA going this way. We have friction on B acting back. And it tells us that it's moving to the right. So if we draw our system out, the only thing pulling to the right is FGC. Pulling this way will be FGA and friction on B. We do sum of the forces equal to N total A. We'll have FGB minus, FGC minus FGA minus friction on B. And that'll be equal to MA plus MB plus MC times A. So this is MCG minus MAG minus mu MBG, no incline, so no cos or sine, MAA, MBA, MCA. We're trying to solve for MC, so you need to take the MCs to the same side. So MCG minus MCA, everything else to the other side. So MAA, MBA plus MAG plus mu MBG. Factor out the MC, G minus A, going to equal all that, divide by the G minus A. So MAA plus MBA plus MAG plus mu MBG. So A was 4 kilograms, acceleration 2, B was 12 kilograms, 2 meters per second squared, 4 kilograms, 9.81 meters per second squared, coefficient 0.25 times 12 times 9.81 meters per second squared. On the bottom, 9.81 meters per second squared minus 2.